We saw Mr. Jason had changed cabbage juice into a variety of colors by adjusting the pH level. Recall that the anthocyanin pigment in cabbage juice changes color because it has 5 slightly different shapes, one for red, clear, purple, blue, and yellow. We can learn how different compounds change the pH level of water and the anthocyanin pigment shape. Let's start with an acid compound in water. The general reaction is that an acid A has an attached hydrogen atom H. In water, a hydrogen atom could leave its negative charged electron attached to the acid and fall away as a plus charged hydrogen ion H+. This makes the acid minus charge A-, which is called the acid's conjugate base. The extra concentration of hydrogen ions H+ makes the water more acidic, which lowers the pH level of the water. In fact, the hydrogen ion will often bond to a water molecule to create H3O+, which is called hydronium. So the presence of H3O+ in water also contributes to the water's acid and pH level. This is the general reaction for an acid compound placed in water. We use vinegar for our color-changing acid because it contains about 5% acetic acid, which has chemical formula C, H3, CO2, H. They form this 3D-looking molecule. The key to making water more acidic is the hydrogen attached to the oxygen atom. When placed in water, the hydrogen's electron will remain with oxygen to make the oxygen minus charged as the hydrogen ion H+ falls away. Losing the H+ ion changes acetic acid to a minus charged acetate ion. Remember that increasing the amount of hydrogen ions H+ increases the acid level and lowers the pH level. The more hydrogen ions falling off means a stronger acid. However, the hydrogen ions do not like to float around on their own, so they often bond to water molecules to create hydronium H3O+. Notice that this process follows the general form of an acid compound making water more acidic. Acetic acid is of the form AH. It loses a hydrogen ion to become its conjugate base, an acetate ion A-. The hydrogen ion makes the water more acidic as it forms hydronium with a water molecule. Can we just keep bombing water with vinegar to make even stronger acids? In other words, can we lower the pH level all the way to 0? Not really. Acetic acid is considered a weak acid. The best it can do is a pH level of 2.5, which is still safe to eat. There are 2 reasons for the limit. One limit is because only 1 of 25 acetic acid molecules give up their hydrogen ion. This is called partial dissociation because only part of the acid supply dissociates. The second limit is because too many acetate ions in the water will cause some of them to want a hydrogen ion back, which it grabs from the water. This reaction changes water into hydroxide OH-. More OH- increases the pH level to make it more alkaline. All the reactions balance at a pH level of 2.5, so that is the acid level limit of acetic acid. The acetic acid in vinegar can change the purple anthocyanin pigment to red because a stray hydrogen ion H+ will team up with an electron from an oxygen atom to make hydrogen, which then bonds to another oxygen. This is the shape for the red anthocyanin pigment. You can use vinegar or a 5% solution of acetic acid to make red cabbage juice. To make reddish purple, Just add a few drops of vinegar at a time until you get the color you like. Tackle the quiz, then we'll see how base compounds create blue, turquoise, and green cabbage juice. For a free lesson plan about color changing cabbage with self-correcting quizzes, go to oinkidoacademy.com. See you in the future.